Hello, everybody. Thank you for listening us. So, yeah, my name is Oliver. I'm from Estonian company called DateL. I'm a head of space domain there. Regarding our company, so we are providing both software development services and also we have our own software products. We are roughly 100 employees. And Estonian context, quite old company, already founded in 1990. And we want to be a good partner for fast development in e-society. What we have been doing, we have done most of this kind of core geo-information systems in Estonia, like starting from cadastre management system, address management system, land registry, land tax planning registry. You can see also like a 3D twin of Estonia. So different kind of systems that are related to the geo-information. And from there, it was also a logical step for us to start processing satellite data. It's also, as this is our stronghold to really process spatial data, everything that is related to the maps. I'm not going too much of the history here, how we developed, but basically the idea is that we developed together with the Estonian state, started to build them this kind of core geo-information systems. The technology evolved, we evolved together with that, and so this was like a path for us. In 2018, we launched our first satellite-based product called Silla. And this is one of the things that I'm going to talk about more today. Before going into, just wanted to also, as this is like a big data event here, and also like we concentrate on the satellite data part here, is that there are different kinds of satellite data. I'm not sure what's your background there, but if I would classify it very simply, of course, there are actually more classifications. It's not only one, like there are other types, there are radar and optical, but this is, let's say, what we process the most, radar part and optical part. So the radar, what is good is that it can see through the clouds. So there is no issue with that can we take the image now, especially with this kind of weather. It is important to see this kind of cloudy days wouldn't interfere. But of course, with optical data, you can actually see yourself and the human can interpret it much better. With the radar data, it feels like a black and white data. I'm not sure how well you see from the screen, but so there are more processing needed to really make it like good insights coming from there. And but today, these examples that I'm going to bring more, although I'm actually covering a little bit of everything, but business applications, I'll start with the one with Sentinel-1. So the low resolution radar data, but what is good about it, it has also this very historic information, so we can go back in time. It always takes the photo, even if nobody orders it. So there is always data available. We can go back in time and check how it was previously, and also it used it quite frequently. Of course, in the business context, it's like basically free. I mean, there's a processing costs, but data itself, it's free. So, but resolution, of course, you cannot really compare it to the high resolution ISI where there's no images. But anyway, there are techniques how to really make it work. And this is our first product. This is based on Sentinel-1 images. So what does it do? It's called we call it Silla. It's an early warning system to understand millimeter scale infrastructure movements. Meaning, for example, if this building moves from one side like 2 millimeters, we can detect it with our application. And as said, we can make this kind of like, as it is based on Sentinel-1, we can create this kind of timelines. You can see historically, okay, maybe it has always been moving, maybe it started just now, and this really helps us to compare these longer trends. And usually when we see, like for us, when sometimes this kind of big catastrophes, infrastructure catastrophe happens, then we go and check, would we have detected it if we would have monitored it? It's not always the answer is yes, we would have spotted it beforehand, but usually like roughly 70% of the cases, we can say that, okay, there are actually quite big pattern changes before this big catastrophe happens. But I will show you more about it here. Yeah, so what we've also been doing, for example, in Baltic states, also including Riga, is that together with ESA, this kind of monthly monitoring every month of the big cities in Baltic states, and with this kind of way, we can really like spot this kind of problems before it might be really catastrophic. But yeah, we can also, our customers are minings, this kind of construction surveillance, and very many different ways how to take use of it. Yeah, and we have done quite a lot of this analysis worldwide. So it's good about the solution is that we don't need to be local somehow. Doesn't matter where the order comes in. We can do it as the satellites are flying all over the world. But let's go with some real life examples. Okay, before going there, so how it works also is that like I'm not going to the very high like science here. What goes on over here? It basically means that there is like a very this kind of scientific methods that are like based on high physics. This kind of radio frequencies, how to read it out. But in simpler terms, what we do, we take this lot of sentinel images, stack it together, we line it, and then we analyze this. How these kind of concrete points are moving over time. And this one analysis, I'm talking about long analysis, like 6-7 years. This means that like you're processing usually like more than half terabyte of data just to break one analysis. So there are like a lot of data involved in order to really make this graph that you saw in the previous slide. Yeah, but let's talk about some real life examples. This came out from this European Space Agency program of the monitoring this 10 biggest Baltic cities, and one of the things that we identified there is one breach in Latvia actually is quite dangerous in our view. At least we see that it should be looked over. Yeah, so this is probably you know the breach, maybe you don't, but I guess locals know that, and yeah, what we are seeing there is that like more than 35 millimeters of movements is going on over there. So we actually also contacted people like responsible people there, and they are actually saying that they are working on to really like stabilize it and start renovating it. So yeah, but although unfortunately this program right now finished, so we are not doing the daily monitoring anymore, or not, sorry, the monthly monitoring anymore. But yeah, we see that it would be really needed for this kind of unstable objects, and like because yeah, it might go bad. Yeah, and this is just all this kind of non-optimized analysis in a way that this came from this kind of big city analysis. If we would do this kind of local analysis for concrete objects, then we could get even more accurate, more better information there, how it moves. So this is what we see, that these kind of objects that are unstable should, like somebody should order this kind of at least monthly monitoring for these kind of objects to really avoid big catastrophes. Because yeah, you can see from this breach also this like when it started more, like you can see the 24 in September there was some big change going on, and now yeah, it has like not like there's something going on here. The latest one was in May. So, and usually actually what we see is that when something really collapses, then beforehand this kind of up and down movement starts to going on. So we are not saying that this is going to collapse tomorrow. No, we are not saying, but we are saying that it should be closely monitored also on site. Yeah.
Because your assessment is based in
Sorry?
It's like bottom winter time.
It's
like I saw that from figures, it was like December. Yeah, am I right? Figures like. Yeah, here. It's like December.
Where did what? Okay.
Last month of analysis.
Yeah. Okay. So this is just a
basically it's like how sure you are that in December you can see these fluctuations, because northern regions, as far as I know, those two winds are they just
you are correct. You are correct that the reliability of the INSAR on the winter times is sketchy. It depends on how much of the snow you have, or where the snow really lies on. Yeah. So this was just an output of what we this slide was just created in December, but here what we can see, it's not based on December. This the last date is May 25 here. So so this analysis was done on every month, including the winter months. And yes, you are correct that in winter months this kind of change might be a bit you need to be more reserved with that when you are interpreting the change on the winter months. But when you're looking down on the full this timeline, you can see that there is this kind of subsidence going on there.
This displacement of the show, is it like displacement relative to sunlight view, or it's like vertical?
Vertical. This is like so yeah. So this concrete slide is relative to satellite, but this actually is vertical. So there are different ways to do that. So this image is vertical, but this is actually relative to satellite. So basically, what we're saying is that we calculated both, just like showing different ways to present it.
But did you get some kind of feedback about this on local authorities?
We got
like real displacement.
We got the feedback that they are working on that, and they have been actually trying to renovate it for a long time, but there are some issues with tender process and stuff. So they are also worried about that bridge. Yeah.
Do you have a local sensors already?
No. We are still a remote sensing company, but we do.
If you put some local sensors, and maybe
No. Of course, but we have we are very confident of our, like I said, we have done more than 4,000 analyses and this kind of calibrating thing. For example, in Tallinn, Tallinn actually uses our analysis to see where they should recalibrate their benchmarks. So this kind of data quality, like for us, this service has been there more than 7 years already. So it's we are very confident of the quality and accuracy there. So for us, we want to give this information that somebody should deal with that, but this kind of recalibrating it, we don't this is not what we do anymore. This is what we did when we came up with the service. But for now, we are not going into there that really start monitoring on the ground. We are saying that it should be monitored, but somebody else kind of should monitor it on the ground. Any other questions? So what's the time situation now? Okay. So just I'm not saying that this is the future of that breach, but just saying that one example how in Germany the breach collapsed. This wasn't in our monitoring, but this is how it looks like when it collapsed. We did this after analysis, and there's let's say there's similar patterns here with the breach in the Daugavpils. As I'm running out of time, just quickly, also another service that I wanted to introduce you guys is this. Now we're talking about the service that is based on not any radar images anymore, but a high resolution satellite optical images. So yeah, here we're using Airbus Pleiades Neo images, and what we do is that we detect illegal constructions with this service. Yeah, what we do is that we take high resolution recent image. We have built our own machine learning model to detect the buildings. Then we are using this construction register information to compare it with and understand where are these like not registered, misregistered, and not registered pools. Yeah, we are mainly focusing that service on the Spanish market, but we also do it in Estonia. Like there are quite a few of those. Like for example, we just recently finished the analysis for Harku municipality, which is like roughly 100 square kilometers, and there was like more than 5,000 not registered buildings. We have actually also talked about few years ago with this kind of service to do it in Latvia, but right now we haven't done it yet. But if you see that it would be useful for you guys also, please let us know, and we are happy to also help with that in here. Yeah, just in one use case of the how it looks like in one Spanish municipality. Yeah, as I'm running out of time, quickly also a few words about the future, what we are working on. So what we are also like working on is to create this high resolution digital surface models from high resolution radar images. So this project that just started in this summer together with the European Space Agency. So it's too early to talk about results yet, but we are also very interested. We are very hopeful that this will be also nice results, and this kind of height models could be generated based on the high resolution radar images. And one more, maybe just to leave it here, this kind of idea, or this is the question mark. Is this the future or not? We don't know, to be honest, but it's a super interesting topic that we are also a little bit looking at. Is super resolution, meaning that the lower resolution images are enhanced with AI. So it means that like here you can see the original Sentinel-2 image and how AI enhanced it. And I mean, it looks so much better than the original image. But the question is the reliability here. As you can, for example, see, this is the real high resolution image, this same area here. As you can see, there's actually a straight road here, but with this AI enhanced, here is some like real issue. So, I mean, it does the guessing, and in general, it does quite good guessing, but it's still a guessing. So there's a kind of question like of the reliability and how much we can really trust these super resolutions. But a lot of people are working with that. Also, Airbus actually now offers to basically enhance this resolution 2 times. So I mean, yeah, this is kind of like, it's a promising, but there's quite a lot of reliability questions there, like how much we can actually trust it. But it's an interesting topic, I think, to look forward in the future. So I hope I didn't go too much over time, but yeah, thank you.